Hello G8 students in our next video lesson. Okay, so first of all, thank you for your homeworks. Almost all homeworks sent to me were solved correctly, so let's check. This is for people who didn't do this correctly. Okay, so this is your last homework, yeah? It was about tension. We have three masses connected by two strings and overall force 20 newtons acting on these three masses. So first of all, you have to find overall mass, which is sum of these three masses, m1 plus m2 plus m3, okay, which is 2 plus 3 plus 5, together is, of course, 10 kilograms. Yeah, and we know overall force acting on the system, 20 newtons, so you can calculate acceleration of the system, force over mass, which is 20 divided by 10 is equal to 2 meters per second squared. Okay, so now maybe let's focus on the last mass on this. Is it clear? Okay, so mass m1 moves with acceleration of 2 meters per second squared, so we can find a force. Force is mass times acceleration, so 2 times 2, which is 4 newtons. So tension 1 is 4 newtons. Is it clear? Okay, now let's focus on another part, on these two masses. Okay, these two masses together, m1 and m2, is equal to 5 kilograms, because 2 plus 3 is equal to 5 kilograms. And these two masses together move with acceleration of 2 meters per second squared. So what is a force acting on these two masses? Force, Ft2, is mass times acceleration, so this is 5 times 2, which is equal to 10 of newtons. Okay? So force acting on these two masses, so force tension of the string attached to mass m2 is equal to 10 newtons. Okay? You can check it. Let's look. Let's focus, let's say, on mass only m2. Yes? m2, which is equal to 3 kilograms. Mass m2 experiences two forces. 10 newtons acting to the right, and additionally 4 newtons acting to the left, the tension of first. So what is overall force acting on this? Overall force acting is difference between 10 and 4, which is 6. Okay, so if we have mass of 3 kilograms, which experiences a force of 6, so what is acceleration? Acceleration is force over mass, so 6 over 3, which is equal to 2 meters per second squared, which is correct because acceleration of the system should be 2 meters per second squared. Is it clear? Or moreover, you can check it in different way. Let's focus on mass m3. Okay, m3, which is equal to 5 kilograms, experiences two forces, 20 newtons acting to the right, and tension of the string 2 acting to the left. Tension of the string 2 is 10 newtons. So what is overall force acting on this mass? Overall force is difference between 20 and 10, which is 10 newtons. So what is acceleration? Acceleration is force over mass, 10 over 5, which is 2 meters per second squared, which is also correct because it should be 2 meters per second squared. Okay, so what is the solution? In the case of solution, first you have to calculate acceleration, which is equal to 2, and then separately last mass, the left, so m1, which is equal to 4 newtons, and separately these two masses, so tension of another string. Remember that this string acts on two masses, on m3 and on m2 and m1, because m3 and m1 are connected together. Okay, so finally at the very end, what is the answer? Tension Ft1, tension of first string, is 4 newtons, and tension of Ft2, tension of second string, is 10 newtons. Okay, I hope your answers are correct. If not, please stop video for a moment, copy this to your notebook, or compare with your, find your mistakes, find your errors. Here you have a correct solution. Is it clear? When you will be ready, turn video back again. Remember, be prepared to the lesson, organize pen, pencil, and your physics notebook. Okay? So when you will be ready, turn video on. Okay. Today's topic is kinetic friction. Okay. What is a friction? Friction is a kind of force. Yes, is a type of force. So friction or frictional force is measured in newtons. Is that clear? Okay. So what is this force? This force opposes the movement of the object. Okay. So when object moves and friction acts, then friction reduces force which pushes object forward. Okay, so this is a force which acts opposite to the direction of motion, because the word kinetic means that object moves. Yeah, so write point number 1. Okay, friction or frictional force. I'm going to use symbol F like force and F like of friction. F, force of friction. Okay, so friction is a force which acts between two surfaces which move one along another. Yeah, so we have to have two surfaces which move. So basically, two surfaces which slide. Okay, sometimes this type of friction is known as a slide of friction. Sliding friction, not slide of friction, sliding friction. Is it clear? Okay. Point number 2. Friction or frictional force opposes the movement. Okay, so it's something which disturbs motion of the object, something which tries to stop the object, something which acts opposite to the direction of motion. Okay, so write in brackets, it acts opposite to the direction of motion. So basically something which slows object down. Okay, so when object moves without friction, then it's faster, or when object experiences a friction, then we have situation when object slows down. Is it clear? Okay, I hope you've copied this. If not, please stop video, copy this, and point number 3. Okay, so write friction microscopic point of view. So microscopic. Okay, what the friction is? Let's imagine that you have a flat surface, okay, on which object is located. And let's imagine that this object moves. So the blue arrow experiences direction of motion. Okay, and let's imagine that this part here is zoomed in. Okay, so what happens here? Okay, this is zoom of this part. Oh, nice. Okay, so what do we have? We have two surfaces. The flat surface, let's name it surface 1, like a floor. And second surface, or a side of this moving object, let's name it surface 2. Okay? So microscopically, surfaces are not perfectly flat. Okay, so surface 1 is not perfectly flat. It makes a kind of shape like a mountains or valleys. Is it clear? And upper surface is also not perfectly flat. So we have something which represents upper surface. Okay, so again, red color represents upper surface, so object which moves. Yeah. Oh, maybe it will be better if I will use this hop. I hope it will be working. Yeah. Okay, so red color is upper surface, so this one. And blue color represents lower surface, so this one. Okay, nice option. Better than in classroom. Okay, is it clear? So, due to the fact that surfaces are not perfectly flat, it's difficult to move object, yes? Like, let's look on this, or this part. Okay, it's very, very, very difficult to move object because surfaces are not perfectly flat. Okay, so right here, something like this. Kinetic friction occurs because surfaces are not perfectly flat. Okay, it's very, 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 very important. Yes, surfaces are not perfectly flat. Okay, please copy this as a point number 3. So you can stop video, copy this, and again, when you will be ready, turn it on, and then next point. Point number 4. Kinetic friction depends on. Okay, so now I'm going to give you factors affecting a kinetic friction. Okay, so first of all, yeah, it must be a type of a surface. So let's look. If you have a flat surface, like, I don't know, an ice, yes, then friction is very, very, very small. If you have a rough surface, like sandpaper, then friction is very, 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 very high. Okay, so basically type of surface means material from which object is made. Okay, so you can write example: flat surface, small friction, okay, and rough surface, huge friction. Okay? Okay, second is this is something which is called a normal reaction force. Okay, so write normal reaction force. But at your level, at G8 level, we are interested only in situations when object is located on flat horizontal surface. Okay, so if horizontal surface, if object is located at horizontal surface and moves in one direction, let's say here, direction of motion, then normal reaction force has the same value as gravitational force acting on the object. Is it clear? So you can write a kind of note here. When object moves along horizontal surface, okay, then normal reaction force has the same value as a gravitational force acting on the object, of course. Okay, and you don't need to care different situations. I promise you in G8 we'll be doing only examples with horizontal surface. So second parameter, second factor is normal reaction force, which is the same as what? As gravitational force acting on the object. Is it clear? So we have type of surface and normal reaction force. Okay? So what is very important? Frictional force doesn't depend on the surface area, on area of contact. Yes, if we have the same object placed in one side or other side and surface is the same and mass of the object is the same, then friction must be the same. Is it clear? So we have two main factors, type of a surface and normal reaction force or gravitational force, which is the same. Okay, please copy this. Okay, and last, let's do example. Okay, and remember that kinetic friction is something which opposes direction of motion. So this is force which acts oppositely to the thrust force. Is it clear? So let's imagine a situation that you have, okay, a box, yeah, which is connected by a string to a force which is equal to, let's say, 20 newtons. Okay, we know mass of this box is equal to 5 kilograms. Yes, and we know acceleration of the box. Okay, and acceleration of the box will be 3 meters per second squared. Acceleration is 3 meters per second squared. Okay, and we know that object experiences a frictional force, so force of friction, which acts opposite to the direction of motion. Usually, friction is created near the surface, so this is why I made an arrow down near this surface. Okay, and your task is to find what is a value of force of friction. Okay, please copy this for a moment. Please copy this now. Okay, stop video for a moment. Okay, copy this and try to solve it, but I'm going to give you one modification. Let's name this force F, I don't know, of the string, force of the string. Is it clear? Okay, so this is just index. I've added just index. It will be easier because usually F is a symbol reserved for overall force, net force. Yes? Okay, so now you have, let's say, 4 or 5 minutes to solve this. When you will finish, or after 5 minutes, turn video again, I'm going to give you a solution. Is it clear? Okay, so let's look. So 5 minutes later. Yes, 5 minutes later. Solution. Okay, so let's look. We know acceleration of the object and we know mass of the object. So by using acceleration and mass, we can calculate overall force acting on the object. Yes, force due to the second Newton's law of motion is mass times acceleration. So 5 kilograms multiplied by 3 meters per second squared gives 15 of newtons. Yeah? Okay, and we know that object experiences two forces. This force of the string which acts to the right along the direction of motion, in the direction of motion, and force which opposes this, force of friction. And moreover, we know this force of the string and we know overall force. Okay? So, what is overall force? Force is a difference between force of the string, so tension, and frictional force. Why difference? Because these two forces, tension of the string and friction, both act in opposite directions. Okay? we have to find FF. So F, which is 15 newtons, is string, which is 20 newtons minus FF. So what is the value of FF? Force of friction in this particular case is 5. Remember about unit, standard unit of force, 5 newtons. I hope you did this in a very similar way. If not, please copy this or correct your exercise, correct your writing. And when you will be ready, turn video again, and I'm going to give you one homework. Okay, so homework related with friction. Just one simple exercise, very similar to one we've calculated. Let's again imagine that we have a flat surface, yes, on which object is located. Okay, and let's imagine that object is connected to the string, and at the end of the string there is a force. Let's name this force of tension in this case, which will be given as, let's say, 50 of newtons. Okay? Object, we know that object experiences two forces which act opposite to the direction of motion. Fa, a resistance, okay, and Ff, force of friction. Okay, is it clear? Yeah, is it clear? Okay, and we know mass of the object. Okay, and we know acceleration of the object. We know that object accelerates to the right with given acceleration, and this acceleration will be equal to, let's say, 1 meter per second squared. Okay? Okay, and one additional information. We know that force of friction, friction force, is 3 times bigger, larger, stronger than a resistance. Okay, and your task is to find force of friction. Yeah, so again, we have tension of the string which acts on the object to the right. We know two opposite forces, a resistance and force of friction, and both act opposite to the direction of motion. And we know that friction is 3 times stronger than a resistance. We know additionally mass of the object and acceleration of the object. Okay, and by using a method presented by me during this lesson, you have to find force of friction. Okay, so please copy this, focus on the problem. You have 1 week or so, okay, let's say 6 days. Do this homework, and you have to attach this homework as assignment in your Google Classroom. Okay, thank you for watching. Any suggestions, comments, write on my YouTube or send to me by Google Classroom. Okay, remember, learn physics, stay at home, and see you next time. Bye.